that are out today. Okay. Let's go ahead and pick, anybody want to start with their problem first? Fatima? You said which one? Number one. Number one is 2x squared minus 72. 2x squared minus 72. The very first step says the second see if it's the greatest common factor. Is there a factor that we can take out of both of these terms, Fatima? What is it? Okay. 2. And it says if there is, then we're gonna factor it out. So that's what we're gonna do. So we're gonna rewrite this as 2 times the factor that will equal that. What's gonna be this factor here, Fatima? Okay. That's right. Okay, so we factored out. So let's go now. Everybody caught up? So let's go down and look at our steps. Wrong way. Are there 4 terms? No, I misspoke there, but I'll fix that. Are there 3 terms? Okay, so let's do it back. So this is the part we're factoring now. How many terms is that? Just 2, right? So there's a factor in 1-term factor and then a 2-term factor. And this is what we're looking at factoring, right? So we're going to go back here. There's not 3 terms. Are there 2 terms? If so, is it a difference of squares? If not, it can't be factored. But if it is, we're going to use our 8-7 note. So, is it a difference of squares? It is. So let's write that in. A perfect square minus a perfect square. That's what makes it a difference of squares. It's got to be minus, and each has to be a perfect square, right? So x squared is a perfect square because x times x gives you x squared. 36 is because 6 times 6 gives you 36. So if you look at your 8-7 notes, it tells us that if it's a difference of squares, we're going to factor it into 2 binomials, but we can't forget we're going to bring down that greatest common factor. There are always going to be 2 identical factors. The first one is always going to be the square root of the first term, and that would be x, right? So you're going to put an x in both sides. The last one is always going to be the square root of the last term, and that's 6. And there's always going to be 1 addition and 1 subtraction. And if you look in your notes, that's what we did in your notes for 8-7. Make sense? All right, who wants to do next? Akira? 2. Okay. 2. 6b squared plus 11b plus 3. Okay. Our first step in our note says to check to see if there's a greatest common factor. Akira, is there a greatest common factor? There is not. So then our next step says, are there 4 terms? Are there 4 terms? There are 3 terms. Okay. So which form? Is it x squared plus bx plus c or ax squared plus bx plus c? Okay. So if it's ax squared plus bx plus c, we're going to use our 8-6 notes. So if you have those, you can get them out and check them out. Our 8-6 notes does tell us to look for the greatest common factor first, and then it tells us our first step is to multiply a times c. What is a and what is c here, Akira? Close. 3 is c. The b squared is not part of a, right? Only the 6. So we're going to do 6 times 3, which is 18. So this is where we have to rewrite this as 4 terms. So the a-6 notes tells you we're going to split the middle term here. So we're going to split the middle term. says we're going to use our x. I am going to tell you, I am going to post the answers to these review worksheets, and I definitely need work for every problem, unless it's one of the special factors problems. But even then, I need you to tell me which it is. Is it difference in squares or is it perfect square trinomial? I need something in all the problems. So to split the middle term, we take our AC, that's our product, and we're looking for the factors of 18 that equal 11. Is this sounding familiar, Akira? Okay, great. So the next thing you need to consider is signs, right? So we're going to get the factors of 18. It's a positive 18, so they either have to be both negative or both positive. Do you know what they're going to be, Akira? So for these, for 18, it's a positive 18, so we have a choice. The only way to get a positive 18 is 2 positives or 2 negatives. Which is this one going to be? That's right, because it's this addition here. So we're going to list the factors of 18, and we're looking for the one, it is -2, because 2 plus 9 equals 11. That is our middle term. So we're splitting the middle term. Everything else is going to be the same. So the 6b squared is the same, plus 3 is the same. This is getting split to 2 and 9. So 2b plus 90. From there, if you're looking at your notes, you'll see now we are going to factor by grouping, because now we have 1, 2, 3, 4 terms. Make sense, Jeremiah? So grouping, 2 groups. If you're factoring by grouping, you're stuck. Remember, that's your 8 notes. So 8 notes tell you greatest common factor of both groups. Add or subtract those depending on the sign. That's going to be our first term. So what's the greatest common factor of the first term, Akira? 2, just 2? 2b. What's the greatest common factor of the second group? 3. And it's a positive, so we're going to add them. Do you remember how to find the other factor, Akira?
You divide the first 2 by the first factor.
Beautiful. By the first, yes, by the first greatest common factor. So 6 divided by 2 is 3. B squared divided by B is B. 2 divided by 2 is 1. B divided by C is 1. 1 times 1 is 1, and that is a positive. Cool? All right. Who else? Who's ready for their problem? Brooklyn? Sure. 13 it is. RS squared minus 2R. RS squared minus 2R. So the first thing we're looking to do is pull out a greatest common factor. Is there a greatest common factor in those 2 terms, Brooklyn? Well, if you look at the numbers, there's not a number in the first term, right? So that's a 1 and that's a 2, so we can't pull anything out numerically. But do you see the same variable in both terms? Yes. Okay, so that means we should be able to pull an R out. Right, so there's an R in this term and an R in this term. So the greatest common factor is R. So our first step says we're going to rewrite it after factoring out that greatest common factor. So now this is the part we're factoring. We know our answer is going to be R times something, I'm not quite sure, maybe 1, maybe 2, we don't know. We're going to go through our steps. Are you with me, Brooklyn? Mm-hmm. Okay. So we've done this one. Are there 4 terms that we're factoring? Mm-hmm. Only there's sorry, this is a bit of pain shooting in my leg right now. Gosh, weird, I've never had that before. Oh, okay. Brooklyn said there's 2 terms. So we're going to go all the way down to here. Is it a difference of squares? So if there are 2 terms, we're looking to see if those two terms are a difference of squares. So remember, it's going to be a perfect square minus a perfect square. Is f squared a perfect square, Brooklyn? Yes, because s times s is x squared, so that's a perfect square. How about 2? Is 2 a perfect square? Do you remember what it means to be a perfect square, Brooklyn? So perfect squares have a pair of identical factors. So 4 is a perfect square because 2 times 2 is 4. Okay? 100 is a perfect square because 10 times 10 is 100. Okay? 2, the only factors of 2 are 1 and 2. 2 doesn't have any identical factors, so 2 is none. So let's see what our notes say after that. If so, the difference of squares. If not, it can't be factored anymore. So our final answer is going to be this. That's all that can be factored out of that one, all right? Who else is ready to do theirs? 17? You can go more through with these. You still need to go. 17 got it? Keep up. TC plus SC minus TD minus SC. Did I write it correctly? TC plus SC minus TD minus SC. Okay. So is there something we can take out of all 4 terms, Bobby? There's a T and a C in the first one. There's not a T in all the terms, and there's not a C in all the terms. So there's not a greatest common factor. Does that make sense, Gladys? There's not a, yeah. So none of these, there's nothing that occurs in all of them. So if we go back to our notes, it says now, are there 4 terms? There are 4 terms, so we're going to factor by grouping. That will be your 8-8 notes. Do you have your 8-8 notes, Gladys? Okay, sit it tall. Sit it. All the way up. Thank you. All right, so what do your 8-8 notes say to do? Where are your 8-8 notes? Where are your 8-8 notes? You are? Okay, get them out and read them. I need to know what is the first step for factoring by grouping? We've already ruled out a greatest common factor. So what's the next step? Parentheses, that's right. We're going to put them into 2 groups. Good job. So the first 2 and the last 2. So now what's our next step? What's it say? Like GCF each group. Yes. So we know we're going to have 2 factors. So what's the greatest common factor of the first 2? Not TC, there's not a T here. There's a C in both of them though. So C is our greatest common factor. Now we need to pull a greatest common factor out of this group. What do they both have? C. And since this is negative, it needs to be a minus C. Make sense? Okay. Now, so we've done this. Now this says, the sum of the 2 factors, greatest common factors is our first term. We've already done that. Step 4, maybe step 4. Okay, so the first 2 terms here, we're going to divide them by the greatest common factor. The greatest common factor of these 2 terms is C. So C divided by C is 1. 1 times T is T. That's plus. C divided by C is 1. S times 1 is S. Okay? Need to figure out a problem yet? Which one? I can't see. 15. Okay. Y'all caught up? Okay, 15 it is. doesn't mean just kidding. Alright, what's that? 30k squared. Okay. Is there a great common factor least? What is it? Perfect. So our notes say to factor that out. So 3 times j squared is 3j squared. 3 times negative 9, negative 27jk. 3 times negative 10, negative 30k squared. Okay, so now what we're factoring is this. Make sense? Alright. So how many terms are there that we're factoring? 3. Okay, so which form is it in? X squared or ax squared? X squared, very good. So it's x squared or you need our 8-5 notes? Okay. So if it's x squared or 8-5 notes tells us this is going to factor into 2 binomials. Got to include this answer here, this factor. So now it's going to look something like this. Okay? Here's the trick. This is the confusing part. Would you agree, Lee? Because there's a k squared here and a k squared here. What's going to be the first term of these 2 binomials? Do you remember? J, yeah. That's going to be pretty easy. We know that's going to be the case. But remember, the last term in each binomial will also is going to equal this last term. So if we have a j squared here, j and j go in the first term. So if the last term has a different variable squared, then we put the square root of that one there. Okay? And then we just do everything the next step. We're still looking for a product of negative 10 with a sum of negative 9. So our factors of 10, 1 and 10, and 2 and 5. What do we know about the, so this is a negative 10. Say again? Okay. Negative 10 and 1. 1 plus negative 10 equals negative 9, and that is what we need. So, negative 10, positive 1, minus 10, plus, we could put the 1 there, but we don't need it. If you put the 1 there on the test, I will take off a point probably. Okay. So you can put it there and rewrite it if you want. Alright? Looked like it was going to be hard, but if you follow the steps, I promise you the steps do make it easier. Okay. So this is the work. Which one are you talking about? The one we just did? Oh, 18? Oh, not that one. So that which number is that? 18? The only work you need to tell me is tell me it's a special product, right? Is that a difference in squares or a perfect square trinomial? Yes. No, not perfect square trinomial. It's a difference. If it's a minus, if it's a binomial minus, with a minus, it's a difference in squares. So, no, this one's a difference in squares. This one, that one, no. Okay, that's a difference. That's a difference in squares. So that's, your work is going to be you telling me that's a difference in squares. Got it? So if you don't have work, that means it's probably a special product, and you just need to tell me which special product it is. Alright, Brooklyn, Lee, Gladys, and Akira and Fatima, I've already done theirs. And my 3 guys in this room, who wants to go next? Anson, Jeremiah, or Jaden? Number 5. A squared minus 24AC. Okay, the first thing we're always looking for, is there a greatest common factor? Sorry? 1. If there's a greatest common factor, that means that there's not a greatest common factor, right? Of 1 rather. But so, yeah, so of the numbers, 1 and 17 or 1 and 24, 2 and 12, we know none of those factors. So there's not a numerical greatest common factor. Is there a variable greatest common factor? A, very good. So the A is the greatest common factor, so now we're going to factor that out. So A times what gives me 17A squared, Jeremiah? Gotta have the 17, or I need that number. So now I have 17A, but I need A times what gives me A squared? A times something equals A squared. What's that something? A times C would be AC, right? Just A. Yes, exactly. Okay, yep, you're right. The minus. Now, A times what will give me 24AC? So we're looking right here. A times something, so A times something equals 24AC. What would it be? No, you gotta have the 24. Gotta do the 24. We already have the A, so we don't need that. We need the C. Okay? So then if you look through our notes, now what we're factoring is this part here. That's two terms. You go all the way down to the bottom of your notes, number 6. We said we're going to see if that's a difference of squares. If it's not, it can't be factored. If it is, we're going to go to our 8-7 notes. So what is a difference in squares? So a difference in squares is a perfect square minus a perfect square. 17A is not a perfect square, so we know this can't be a difference in squares. Alright? So that is your final answer right there. Who wants to go next? Anson or Jaden? Number 3. Okay, Anson, you got yours ready for next time? Okay. Number 3. Number 3 says 36t squared. 36t squared minus 24t plus 4. First thing we always do is what, Jaden? See if there's a GCF. Yep. Is there a GCF in this problem? What is that? Perfect. So if there is, we're going to factor it out. So 4 times what gives me 36t squared, Jaden? 9t. Perfect. Bring down our minus. 4 times what will give me 24t? 16. Exactly, correct? Bring down a plus. 4 times what is 4? 1. Okay. So we know 4 is going to be part of our answer. Now we have a trinomial. Now, looking at your notes, look at the 3 term questions, right? Which one is this? Is this x squared plus bx plus c, or ax plus bx plus c? Ax squared plus bx plus c. Ax. So that is our 8-6 notes, right? So for our 8-6 notes, these are the notes that we're splitting the middle term. We're going to wind up with 2, a greatest common factor, and then 2 binomials. So I'm going to erase this here. Alright, so what I'm factoring is this part here. Okay? So for factoring by grouping, if we go to 8-6 notes, it tells us we're factoring this by grouping, right? What's your first step? Perfect. So what is the A and C here? So that's 9. So now what we're trying to find is what are we going to split our middle term into? So to factor by grouping, we need 4 terms, and we only have 3. So we're looking to see what are we going to split this negative 6t into. We know our first term is going to be 9t squared. We know our last term is going to be plus 1. We're going to fill in here. So AC is our product, and our sum is going to be the middle coefficient. Does that make sense? Our product, what our factors multiply together is 9, but they have to add together to get -6. Does that make sense? negative 3 is positive 9, and negative 3 plus negative 3 is negative 6. That's exactly what we need. So when we rewrite